All right, welcome to section 11.4 on the quadratic formula. So our objectives are solving quadratic equations, finding and applying the discriminant, using intercepts to graph quadratic functions, and solving quadratic equations that have complex solutions, hence the imaginary solutions. So what is a quadratic formula? Well, if we have a equation ax squared plus bx plus c, again, a cannot equal 0, we can solve for x by plugging into a minus b, just taking a and b and c here, plus or minus the square root of b squared minus 4ac all over 2a. So let's do that with this equation. So we have A is 4, B is 3, and C is -8. So we're just going to plug it in, and we have the following. Minus 3 plus or minus the square root of 3 squared minus 4 times -8 times 2 times 4. Okay, so that's going to be what you have to do. Now, when we plug this in and solve this, we just have to do this in our calculator simply, and we're going to do it with radicals still. And so we're going to have the 3 squared is 9, and then we have minus 4 times the -8. So it's going to be plus the 8 times 16. So that gives us 137. And now we have this. And again, depending on what they want, most of the time they're going to say, okay, that's good as far as your final answer goes, because that's the exact solution. And so I guess I should say you get two solutions. You have the plus of it and the minus of it. But again, it doesn't matter too much. Now, if they do want you to put it to a certain decimal, then, if they want it to the hundredth, then we would calculate it. We'd take -3 plus square root of 137, that whole quantity. And when you're plugging it into your calculator, don't forget to plug in the parentheses on top, or what you're going to do is you're going to take -3 plus this divided by that, and you're just going to do that division and have the -3 in front. So be sure you do that. And if they want it to the hundredth, it's 1.1 and a -1.8. If they want it as exact, you leave it like this. Now, graphing it, we just plot some points, graph it, and we can see that we're going to have that value over here, the 1.1 and -1.8, so -1.8, and then this is going to be about 1.1, and that's what our graph is going to look like. Okay. What about this one? Again, A 3, B -6, C is 3. Plug those all into our function. X equals minus B plus or minus square root of B squared minus 4AC over 2A. Memorizing this is going to really help you be able to solve all kinds of quadratic equations. So we plug all those values in, simplify. Well, guess what? When you plug all that in, you get 0 here. So it's just 6 over 6. So that's just 1. So that's our solution to this one. So graphically, that means we're just going to get one answer. So that's at 1, 0. Okay. And, or, yeah. Uh, X equals 1. Yeah. No. Yeah, so if we plug in 1 here, we have 3, plus 3 is 6, and then -6, so that gives us 0. So yeah, that's right. All right, so that's going to be our solution. What about this one? A is 2, B is 4, C is 5. Again, plugging all those in. Again, just making sure you, when you do these, if you have a negative b, you put that negative inside a parentheses, so when it squares, it becomes positive. A lot of people are going to forget, because here, they're going to forget to put in the -6. The whole thing squared is 36. They're just going to say a minus, and then I'm going to take 6 and they're square that, so it's going to be a -36. So you have to remember to put parentheses around this. So I remember to kind of remind you for that here. 4, doesn't matter because it's gonna be squared, so it's gonna be okay. And so we get -4 plus or minus the square root of -24 over 4. Now, what does that mean? That -24 there, that's going to give us an imaginary number. So that means there's going to be no real solution. So we can't really graph this one, or it's not going to be on the graph. It's going to be somewhere above it. It's not going to be a real solution. And so that's going to be what it looks like here. So that's going to be our answer to this one, graphically as well as numerically. All right, so let's stop there and we'll come back for some more.